have an indefinite integral, and it's the indefinite integral of e raised to the arc cosine or inverse cosine of x dx over the square root of 1 minus x squared. So one thing I'm going to do first is, because this tends to upset people or confuse people sometimes, when you see that dx in the numerator, all that's it's just kind of a shorthand, quick way of writing. I think it's a textbook way of. Well, I mean, you can write it that way, but I'm just saying it's a textbook way of saving space, technically. But it just I think anyway. That's what I'm thinking. So you can just rewrite it like this. That's what it means. So don't be confused about it. Although that might not help you actually know what to do. At least it's not totally freak you out. So anyway, the best thing I can tell you to do here is, I mean, usually, we let u be under what's in the denominator, what's under the radical, what's in the composition. Man, there's all that going on here. I mean, there's a denominator, there's a radical, there's a composition, there's this arc cosine thing. So really, you really need to fall back on what can I set u equal to, and take its derivative, and its derivative is present somewhere in the integrand. Well, if I set u equal to the square root of 1 minus x squared, well, I'm going to get, what, negative 2x over, no, actually negative x over the square root of 1 minus x squared. That's not in here. Part of it is, but part of it isn't, and doesn't do anything with this arc cosine of x. So really, I mean, honestly, I guess my best tip whenever I say e raised to something, it's usually I'm going to set it equal to the argument of the exponent of e. Just because I know that that's going to be really easy to integrate, and I'm just going to hope. But also, I mean, doing what I suggested first would not do anything about this power of the arc cosine of x, and that would just be crazy to try to integrate. So my suggestion would be is to set u equal to the inverse cosine of x. Excuse me, and hopefully you know your derivatives of your inverse trig functions. And so then you would know that du equals negative 1 over the square root of 1 minus x squared dx. And the only thing different over here is I have the 1 over 1 square root of 1 minus x squared right here dx. So I can say that negative du equals 1 over the square root of 1 minus x squared dx. And then I can just substitute that in. The power of e is now u. Du is now negative. I mean, dx over the square root of 1 minus x squared is now negative 1 times du, which is just negative e to the u du. And I mean, who can't integrate that? Negative 1 is a constant. Integral of e to the u is a copy of itself plus c. Wow, that was easy. So now we just sub back in for u, and we get negative e to the arc cosine of x, or inverse cosine of x, plus c. And wow, that was really ugly looking, and it ended up being not very hard at all, really. It really hinges, I think anyway, because hopefully you wouldn't get discouraged if you did set it equal to the denominator. You would quickly see it, well, that didn't work. So you would try, if you didn't try it the first time, setting it equal to the arc cosine. And the only thing I could think of is just not knowing the derivative at that point, because once you made that decision to let u equal the inverse cosine of x, this should actually be a pretty straightforward problem, even though it looks pretty crazy.